1.
This is our first section, algebra review, section 1 and section 2. We're going to put these together. Most of this should be a review for you. We'll find out. We're going to talk about order of operations, PEMDAS, if you remember that, substitution, absolute value, and some different properties. I'm going to attempt to go back and forth between the main screen that you see here and a document camera. Hopefully it works for you. You can see everything. If you can't see everything, please let me know. All right, so the first thing we're going to talk about, order of operations. So I said PEMDAS before. If you haven't heard that acronym before, the order of operations is that when you're evaluating an expression, when you're trying to figure out the answer, we need to do any kind of grouping symbols first. And I am going to make a point of these. I put grouping symbols, and in parentheses, I put parentheses. There is a reason for that. There's not one type of grouping symbol. There are parentheses, and that's why you see the P in that acronym. However, it really should be GEMDAS with a G, because there's more than one type of grouping. And here I'm going to attempt to move over to a document camera. So hopefully this works for us. So here we go. So there are parentheses. Absolutely, we can use parentheses. You might also see, so I'm going to go like 5 plus 11. You might also see square brackets. Nothing really different with that. It's just a different way of writing a bracket, or parentheses. More importantly, though, a square root, or any kind of root, really, called a radical sign. Could be a cubed root, a quartic root, but a square root is a type of grouping. So if you had 7 plus, 18, and you wanted to find the square root of that, you would not do the square root of 7 and then the square root of 18. You would do this grouping first. You would add 7 plus 18 first, then you would take the square root. Same thing with a fraction bar, a ginormous fraction bar. If you have some mess of stuff on top, minus 4, there we go, all over, we'll go square root of 7 plus 18. That just looks fun, doesn't it? You would do, even though they're not up here, we would do the numerator first and the denominator first before we dealt with it as a fraction, before we did any division. And so how I mean that is everything in the numerator would need to be done before we got rid of that fraction bar. So you would have to do 5 plus 11, which would be 16, minus 4 would be 12, and then you would do the denominator. And so 7 plus 18 is 25, square root of 25 is going to be 5. Then you would look at this fraction, you would do 12 divided by 5 and get your result. And so you would need to do everything in the numerator first, everything in the denominator second. And so it is a form of grouping, even though we don't see any grouping symbols necessarily. You do need to treat that as a form of grouping. So grouping symbols first, then you move on to exponents, then you move on to multiplying or dividing from left to right. And that is important, that it isn't just multiplying and then dividing. I know it's PEMDAS, but the M and the D could be interchangeable. It could be grouping, exponents, divide, then multiply. You have to read from left to right. And so that left to right is important. I'm going to show an example of that here in a minute. Then add or subtract, again, from left to right, whichever one comes first. Subtracting might come before addition. It depends on the problem, but we read from left to right. So here's an example. We've got two calculators. One is a phone calculator. One is a Casio handheld calculator. The same expression is put into that. However, they get two different results. One is 9. One gets the result of 1. One of them is wrong. So take a minute. I've kind of rewritten it over here. Take a minute and try and solve, or try and evaluate this expression, figure out what the answer is, see which of these is right, and then I'll tell you which one is the correct answer. All right, I'm going to assume that you spent a minute here or two and tried to get the correct answer. Pause it if you need to, but I'm gonna go over to the document camera again, and I'll work it out just to show you how it's set up. If we follow our order of operations, if we do our parentheses first, we would do the 2 plus 1 first, which I'm sure many of you did. And that's really not where the tricky part is. It's what to do next. If you just did 2 times 3 first, then you would get 6 divided by 6, which would be 1. However, that is not following your order of operations. Order of operations says we do multiply or divide from left to right. So if we read this from left to right, we would do 6 divided by 2 first, which would give us 3 times 3, and 3 times 3 is 9. So the correct answer here is 9, and it's the fact that we have to read from left to right that does make a difference. So make sure that you are following that order of operations as we go through this class, as we go through any math that you're doing, and be careful with that order of operations. All right, so that's order of operations. Substitution. So you've probably seen this before. The idea is we know what x is, we know what y is. We're not solving for x and y. We just want to evaluate it, find the answer. What is the value of 7x minus 12y if x is 10 and y is negative 4? If x is 1 and y is 11. So take a minute, try this on your own, see if you remember how to do this. And if you do, great. If not, then I'm gonna work through them quick and show that step. I'm assuming you paused it. I'm assuming you tried it. So to speed up the video, I'm just going to glaze over that and say you can pause this and try it on your own. And I'll do a fair amount of that. So in this first one, and now I forgot what they were here. Hold on. So we've got x is 10, y is negative 4, x is 1, y is 11. So going back to that document camera, if we substitute, so we know that x is 10, so we're going to replace x with 10, 7 times 10. And we know y is negative 4, so I'm going to replace y with negative 4, minus 12 times negative 4. I'm going to follow my order of operations. I'm going to do multiplication first, 70, and I'm going to get negative 48 there, 12 times negative 4. And this is where you have to be careful. This minus 12 times negative 4, it's a 12 times negative 4, which gives me a negative 48, but it is subtract. So it's minus negative 48. And I'm going to touch back on this here in a second. 70 minus negative 48, you can either view that as adding a positive, but when you take away a negative, that's like adding a positive, and you end up with 118. That's the final answer there. One other way to view this, so I'm going to jump down to the bottom here. Another way to view this is negative 12 times negative 4. So negative 12 times negative 4 would be a positive 48, which gives us the same result, 118. And so this problem could be viewed in a couple different ways. It could be a positive 12 times negative 4 and subtract that. Or you can view this as a negative 12 times negative 4. And that does work for those of you who are skeptical, because you can always change subtracting a positive, minus 12, to adding a negative. Subtracting is the same as adding the opposite, adding negative. So you can use that property to help. For the last, or the other one then, same idea. We can replace x with 1. We can replace 12 with 11. And you'll get 7 minus 131, which is going to give you negative 120 something. Boy, my brain just kind of went, it's going to be negative 124, I believe. And there we go. So you will have problems in your assignment that ask you to do some substitution. Absolute value. So we're skipping ahead here to absolute value. Absolute value is the distance a number is from 0. So it doesn't always make, it doesn't take the opposite of a number. It's not what's called the additive inverse. It doesn't take the opposite of a number. It always asks how far from 0 is this number. And so when you're looking at like the absolute value of 5, absolute value, we use these vertical bars to represent absolute value. So the absolute value of 5 is 5. Because 5 is 5 away from 0. Similarly, The absolute value of negative 5, absolute value again by these vertical bars, the absolute value of negative 5 is positive 5.